All right. Hello to anyone watching this. My name's Rajan. I am the 2023-2024 Suspension Division Lead for Clemson FSAE. I'm a third-year mechanical engineer. Hopefully, you're watching this design season, but if you're watching it in the future, nice to meet you. Today, we're going to get started with how to design a set of control arms. So for our control arms this year, it was a bit different because we moved from a design where we used round tubing all the way through for our steel control arms to now having flattened ends. To be able to properly model those flattened ends, I wanted each of them to be in a separate body, so that way I could make molds for them. But those separate bodies don't really play well with each other, and I couldn't add fillets to them when it came time to do FEA on these. So we're using single part files to make a set of control arms that we can actually do FEA on and model fillets to simulate welds. So I'm going to now share my screen, and we'll see ourselves in an assembly called FEA CA working assembly. For the file path to this assembly, it's right here. It's under control arms, Rajan work. Heads up, this is not good file structure. It's just I wasn't on this design project up until very recently. So here it is. It's under FEA files, FEA model working assembly, and then you'll see FEA CA working assembly right here. Do keep in mind all of this is under the 2024 folder. Depending on how far in the future you might be watching this, there's a chance that folder doesn't exist. Sorry, you're out of luck. But back to our assembly. The first thing I've done is created two folders over here, one for geometry and one for the control arms. For the geometry, I've loaded in my control arm final geometry. This is a stick model for what each of the control arms on the car are going to look like, and it shows us what shape each of these arms need to be. Second folder is control arms. Here I've created a part file for the front upper control arm, front lower, rear upper, and rear lower. Labeling these is super important, and organizing everything in a good folder structure is also super important, but I won't spend too much time on that. For this tutorial, we're going to be using the rear upper control arm as an example. Depending on which one you're working on, I'll tell you at different points in the video where you can stop, because the rear upper, especially with the toe link connected to it, has the most features. So we're going to hop right in and hit edit part. And I'll drop down on the tree right here. The very first thing that we want to do is convert entities to get our control arm geometry into this part file. So let's select each of those lines for the rear upper control arm and hit convert entities. Did that work? No, it did not, because I'm not in a sketch. So let's hit sketch. It needs to be a 3D sketch. And let's select all of these lines again. Again, here we have these two lines representing the control arm, and then we have a third line representing the toe link. Let's hit convert entities, and now we have that geometry in our sketch. If you're working on a different control arm, again, use the geometry for that arm. But like I said, for this example, we're doing rear upper. Once you've brought those sketches in, it's important to exit the sketch and name our sketch. So let's call this RUCA, rear upper control arm, geometry. Properly labeling everything in the tree makes it so that when people come in and might have to debug this or work with it in the future, they know what's going on. Next step is to add a plane. And so let's select two of those lines as our constraints. Let's do both of the control arm lines. They do all lie on the same plane, but just for consistency across the control arms. So let's select both of these arms, and now we have a plane that is perfectly parallel with the plane of the control arm. All right. And we're now going to name that feature if it shows up. There it is. We're going to call that the RUCA plane. I'm going to say it again, but won't say it again after this. Depending on which control arm you're working on, please do change the naming. Don't just make a plane for the front upper and call it RUCA plane. Now that we've got that made, we're going to get started with our bearing cups. So what we want to do is start a 3D sketch. And we'll start on the A node over here. In case you're not familiar already, the A node is the inboard node that faces the front of the car. The B node is the inboard node that goes towards the rear of the car. And the C node is the outboard node. So I'll be using that A, B, C terminology pretty often through this video. Now we want the bearing cups to stay, we want them to stay in the same plane as the control arm and want them to be parallel to that plane. So what we're going to do is add a midpoint line for construction, and we're going to add it right here. For now, draw a completely arbitrary line because we're about to add a sketch relation that'll define that. And so now we select this line. We'll hold our control key, go into the tree, and then select the Ruka plane. And we want it to be normal to the Ruka plane. Normal meaning perpendicular in all directions. It's pointing straight up. Now that we've got that made, it's time to start our bearing cup sketch. For these bearing cups, this geometry should hopefully already be derived. These are made in relation to the bearings that you'll be using. So over here, since we're working on an upper control arm, we'll use this. And this year, we're using an HAB 4T high angular displacement bearing. So this is what our cup looks like so far. We'll go in here. We'll take a look at this sketch. And this actually should be in MMGS because I think that's how I spec'd it. Let's find out. Never mind. I think I might have done it IPS. So all of this is made in relation to equations that sit right here. All right, so some of these dimensions are IPS and some of them are millimeters. It's not very good. Please have dimensional consistency. I did this. This is bad. So here's what we'll do. We're going to take a look at this geometry and we're going to mimic that on our, or in our control arm part file. So we're going to go in here and then go back to this part file. We're still in that 3D sketch for our first bearing cup. And what I like to do is actually create a plane that is coincident here. So we're going to exit this 3D sketch and we'll rename this a bearing cup reference line, because that is the line about which we're now about to revolve our bearing cup. Here for further clarity with these bearing cups, there's a single sketch over here that then gets revolved. For a better picture here, that'll help. We use the revolve feature to spin it around a reference line, so that way it's all fully concentric. Back to the control arm assembly. All right, now that we've done that, we're going to add another plane, and we want it to be on this line, but that's not quite well defined enough. So what we'll do is just make it parallel to our front plane. Oh, it doesn't like that. I guess perpendicular is fine. All right, so perpendicular to that front plane. And we're now going to rename that plane. Sometimes it takes a while for features to appear in your tree. So be sure to hit Control B or rebuild to bring those features back. We'll call this the A bearing cup plane. I call it the A bearing cup plane because it's a plane for us to make the bearing cup on the A node of this control arm. And we're now going to sketch on this plane. I'm not the biggest fan of how SolidWorks just kind of snaps to views normal to that. I like to stay in different views, but oh well. It's a rant for another day. What we're going to do now is roughly and not very accurately sketch out an outline of what this bearing cup should look like. And I know this because I've made bearing cups a good number of times. And it's okay if none of these lines are perpendicular or parallel to anything. But what I've done here is just made sure that I have a central area for this bearing cup, and actually did this wrong. And we'll do that and that. Oh, hold on. I think this gave itself a relation. It did. Wait, yeah, we'll do this. So, yeah, when it comes your turn to make these, just look at either the bearing cup geometry or What I've done here is made sure that the bearing has a bottom shelf to sit on, make sure that it's got a side housing and a snap ring groove. So here's what we'll do now. It's time for adding a bunch of our relations. Now, go in and delete any and all relations that might have come up, because a lot of times when you're sketching on planes, things like to give themselves horizontal and vertical relations. So yeah, this right here has a vertical, that there's got a horizontal. Just make sure you get rid of all these. I was trying to see if I could do multi-select instead of individually clicking these lines, but yeah. Get rid of every sketch relation that may currently exist. All right, and just making sure. Cool. So now here's what we want. We want this back part to be parallel to our reference line. So we're going to add a parallel relation there. And we know we want this top part to be perpendicular. We also want this bottom part to be perpendicular. Bing. All right. Now we know we want this right side over here to be perpendicular to the bottom part. We know that we want the shelf area to be perpendicular to there. Now we can either do a parallel relation to this back over here or a perpendicular relation down here. They're going to effectively do the same thing for us. And now by making sure that all of the lines are perpendicular to each other, we are ensuring that there's no goofy vertical or horizontal relations anywhere in this part file, and everything is properly defined. All right, so now everything should be well defined. And if I go in here and try to add a perpendicular relation, awesome. Next thing we want to do is keep both of these interfaces collinear with each other. That's because we want a constant inner diameter. And this right here just represents our snap ring groove, which has the proper relations. Very cool. And now it's time to dimension everything. All of our features should be moving properly. Very nice. Now, we want to make sure that this bearing cup lies in the middle of the node. So what we'll do is add a construction line. The reason we do this is because we want the center of the bearing to be at the control arm node that was designed. I'm going to do it for construction, and yeah, we'll do a midpoint line. So I want to add this midpoint line, again, completely arbitrarily at the moment. It is for construction, so it really doesn't matter. And then we want to come in and give it a perpendicular relation right there. So since we want this bearing cup to be symmetric, we want the midpoint of that back face to also be coincident with that line. So now these two lines right here, they share a middle. And we also want this midpoint line to be coincident with our control arm node. Awesome. So now, if I come in here and change the height of the bearing cup, you can see how it changes symmetrically. Very cool. Now it's dimensioning time. I misspoke earlier. Let's go in here and take a look at this sketch. These are all equations that I used and will be super, super useful. So we're actually going to emulate the equation setup. So go into your tools, equation tab, and you'll see we've got equations for the bearing radius, bearing housing height, snap ring groove height, snap ring groove depth, the total height of the cup, the wall thickness of the cup, and the radius that that lower shelf sits at. So let's go ahead and do that in our part file. So we'll go to tools over here, hit equations. First one is going to be bearing cup height. Give this something completely arbitrary for now. Or no, not completely arbitrary. We'll do 0.4. And then we want, or yeah, right now do arbitrary values because we're going to go back and put the correct values in here later. But for when you're making this, just copy what I'm doing. And we want bearing radius. And this will do a 1/2 inch. When you're doing these, I just forgot, but make sure to specify your units. This is so that when you go in and change your document units, it'll auto update. And we want the bearing height. We'll make this 0.3 inches, 0.25 inches for now, I guess. And we want our lower shelf radius. We want this to be less than whatever we put for the bearing radius. So I'm going to choose to put 0.3 inches. We now want snap ring. Did I spell that right? I did. Groove height. This, I think, is somewhere in the neighborhood of 1 millimeter. This is because our snap rings are spec'd in a metric way for the ones we're using this year. And then we want our snap ring groove depth. And we'll also make this 1 millimeter for now. Let me see if I'm missing anything. We've got, oh, we need bearing wall thickness. And for bearing wall thickness, we'll do 0.2 inches. So we've now accounted for the height of our bearing cup, the radius of our bearing from the center point, the height of our bearing, this line right here. We've accounted for the lower shelf radius, which is the distance from this line to the center point, the snap ring groove height, and the snap ring groove depth. Perfect. This gives us everything we need to be able to start dimensioning. So go back in, edit your sketch. It's going to snap to a funky view, but oh well. I should probably get a space mouse at some point. That'd probably be fun. All right. And let's start dimensioning. First thing we'll do is come in here and we'll dimension our bearing height. So make sure you type equals and then start typing the name of your variable, bearing height. By typing that equals, we make sure that every time we update it in the tools equation, it'll auto update here. I wonder if I move my camera thing on here. Can you guys see that? If you can, leave a like, comment down below. Let me know what you think. But I'm sorry, guys. Oh well. Yeah, if you can see my video up there, that'd be pretty cool. All right, so we've defined that. Let's go in and define our snap ring groove height, which is this distance right here. So we'll do our equals again, start typing snap ring, and we'll see snap ring groove height. Awesome. We'll now dimension our snap ring groove depth right here, which is this distance. And so type our equals snap ring groove depth. Sick. Now we want to do our bearing cup height. Also, the way you know you've done this right is if a little red summation sign pops up next to your dimension. We'll spec our wall thickness equals bearing wall thickness. Excuse me. I wonder why this isn't defined. Oh, okay, that makes sense. All right. And now we dimension our bearing radius, which is this distance to the center line. One cool thing that construction lines do is I think sometimes you can specify a diameter. So it'll like auto snap to outside of that and give you a diameter rating, even though you're actually dimensioning a radius. It's kind of cool. I wasn't able to replicate it right there, but if you ever come across it, that's what that is. And we'll look at bearing radius right here. Awesome. And then we'll do lower shelf radius. So this is what our bearing cup's going to look like for now. What I'm going to do is, yeah, leave it like this for now. Then we're going to go to features, do our revolved boss base. And our line of revolution is not that line. Clear those selections. We want this to be our axis of revolution. And you can see that it auto snaps and gives us an update there. So just like that, we've got our very first bearing cup, but Oh, we have to control B for that feature to show up. There it is. We need to label this. So let's call this our A bearing cup. Now, since we've done this, we can go back to our original sketch and cross-reference all of our values. Let's go to Tools. I'll rebuild this so we're not stuck in that sketch view. Equations. So our bearing radius is 0.74 over 2, and our housing height is 0.255. Let's run it back. I already forgot the number. Here's what we'll do. We'll take a picture of this. This will make it real nice and easy to remember. Awesome. And if you guys are wondering what I'm doing with this picture, I'm DMing it to myself on Slack so I can look at it. An alternative option is to paste it in Microsoft Paint. It effectively achieves the same thing. And now since we've dimensioned everything properly, sorry, my hand was all up in the camera, if you guys can even see that. We'll go to our equations tab over here and then just start filling in numbers. So bearing cup height, we're looking at 0.4 inches, so that one is good. Now for bearing radius, we're looking at 0.74 over 2. Oh, remember to put inches. Awesome. For our bearing height, we're looking at 0.255 inches. Ooh, I was close. For our lower shelf radius, we're looking at 7 millimeters. For our snap ring groove height and depth, okay, height is 1.1 millimeters. And depth is 0.5 millimeters. Just a reminder, if you're working on a lower control arm, you should be using the bearing cup dimensions from the lower control arm. So I'm reciting these right now, but these are for my upper control arm right now. For wall thickness, what is it? Oh, sick, a 1/10. I'm probably gonna have to up that. Oop. That's 0.1 inches. And let's double check all our values. We've got our total height at 0.4, our snap ring dimensions at 1.1 by 0.5. All right, looks good to me. We click OK and watch as the magic happens. Bam, it just auto-updated. I didn't have to do any extra work. It's perfect. And now we've done a lot of the heavy lifting at this point. So let's go ahead and make our bearing cups for the B and C nodes. These will go a lot quicker. So if you guys remember the process, we'll be doing a 3D sketch and we'll insert a line that is for construction and at a midpoint. We'll do our C point right now, or B, sorry, misspoke. And make sure that this line is normal to the Ruka plane, or whatever control arm plane you're working on. Ding, sick. Make sure to then rebuild, go in and name your sketch. So this is B bearing cup reference. Did I say reference line before? I did. I should stay consistent with that. Now we're going to go in and add our plane. Remember we chose this axis and then we chose the front plane and made it perpendicular to that. Awesome. We're now going to come in and rename that plane B bearing cup plane. Plane. And then we're going to select that and go to sketch on it. Might start adding background music to these videos. I feel like there's been a good couple of awkward silences. Go in and sketch your rough outline of what that bearing cup should look like. Again, only reason I know this is because I've made a shit ton of these. Man, if I upload this to YouTube, I'm gonna get demonetized now. I just said shit. Oh well. Go in, make sure there's no relations that you don't want there. I like to just delete all of the relations so that way I can start fresh. All right, we're good there. Remember, we want this to be parallel with our reference line. And then we start doing all of our perpendicular relations. I really wish I knew a keyboard shortcut for perpendicular relations. There's a chance one exists. I just haven't looked at it. Oh, I deselected. If you haven't plugged in your laptop to charge yet, there's a good chance you're running low on battery if your laptop's anything like mine, so let's go ahead and plug those in. Comment down below what your battery percentage is while you're doing this. Did I just do these? I did. All right. Awesome, that's well dimensioned. In comes our horizontal construction line, construction midpoint. We're going to use that midpoint, draw it arbitrary, and make that perpendicular to here. Make those coincident. And then we're going to bring that line all the way to our node. Coincident. Yeah, I forgot to make these two collinear. Awesome. We'll start with our snap ring dimensions. Fun fact for us, now that we've defined those equations, we can just do snap ring groove height right there. This will be our snap ring groove depth. That's why I like using equations. Just saves a lot of time in the grand scheme of things. This is the kind of boring part. Just dimensioning everything. What time is it? All right. That's not where we want it. We want this to be on the other side of this line. Cool. Back to smart dimensioning. We'll give it our height. Again, don't forget to do your equal signs. If you don't see that red summation mark, that means it's not going to auto update. And being able to update things with the equations is going to be super, super helpful for us when we're running through iterations with FEA, because there's a chance we might want to change some of these dimensions, and going in and individually changing all of them really, really sucks. I don't know why I called that bearing wall thickness. I should have just called it wall thickness. Made my life easier. We'll give this our bearing radius. Right now, on purpose, what I'm going to do is not type the equal sign when I'm dimensioning this. I know this is called lower shelf radius. So here's the thing. It auto inserted the value for that variable. But now, without that red summation sign, if I change my lower shelf radius value, it's not going to auto update. So we're going to do our equal sign, lower shelf radius. One thing that we haven't done so far is add chamfers to these. And the reason behind that is there's no reason behind it. We should have added the chamfers, but it's fine. We can just do that later. If you want to add chamfers, just do it on this node and this node. Chamfers are good. They add range of motion clearance and they remove weight, which is always nice with race cars. Do our revolved boss base around this line. Look at that. Got ourselves another bearing cup. That one was a lot quicker than the previous one, but we're not done yet. Time to do it a third time. Oh, what are we forgetting? We didn't rename this. This is our B bearing cup. Please, please, please keep naming your features. If you're watching this in the future, I will rise from the dead and come and force naming of your features. All right, so now another reference line for our C-bearing cup 3D sketch. While I was speaking very slowly and pausing there, you noticed a massive skill issue on my part. I couldn't figure out why it wasn't doing a 3D sketch. It's because I was clicking the line button and not the 3D sketch button. Silly me. Let's make this normal to our control arm plane. And hopefully by now you're pretty comfortable with this procedure. Oh, we need to rename this. Well, let's rebuild it first. Every subsequent time you do something, it just goes quicker. C bearing cup reference line. I recommend using shorter names sometimes. Most of the time, please use shorter names. It's gonna save you time in typing. But usually longer names are a little bit more clear, depending on how much detail you want to convey. We're now adding our reference plane for the C-bearing cup. Let me know if you guys like this kind of work alongside me type of video, or if you'd rather prefer different cut sections where, I do something and then just cut to me doing the next thing, and then, y'all do the stuff in between. As in, I would have just made one bearing cup and then you do the rest of them. There. We're back to sketching on this plane, and let's make our rough bearing cup outline. This time I'm going to do it on the right side of the line. Yeah, switch it up a little. And this is a really good example of how just not that great it has to look initially, because you're going to add a bunch of sketch relations later. Just make sure that you have the right amount of lines and delete any and all possible vertical and horizontal relations. That's why I like to do them at weird angles, because if you do them at weird angles, then SolidWorks doesn't auto snap horizontal and vertical relations to them. But now that we've done this, we go in here and start doing each of those features, or relations, not features. This video is really meant for just Clemson people to be using, but if there's a chance that someone in the future is watching this from a different university, what's up? Hope the weather's nice. Comment down below what university you're. I need to stop. All right. That was the last comment down below joke. We're done. Are these not perpendicular? They're not. Okay, that's better. Those are. We'll go here. Then just two more left. I love seeing it snap into place as you get more and more defined. Look at that. That's a peak bearing cup right there. Make these boyos collinear. Sick. And let's not forget our construction line. Construction midpoint. Again, the reason I draw these at funky angles is so that SolidWorks doesn't auto-create sketch dimensions for me where I don't want them. Make you perpendicular. Bring you onto there. If it ever goes self-intersecting at some point, just fix it. You can click and drag all these lines because they're not defined yet. All right. Oh man, I made a mistake. Forgot to add a snap ring groove. So here's what we'll do. We'll delete, and then I still don't know. So you see right there, it's trying to snap a relation. If I just do it at an angle, it doesn't do that. Holy shit, that's just wrong. What am I doing? Hold on. Sorry, guys. It was correct the first time. I don't know why I deleted that. Yeah, I just made the wrong two things collinear. That was my issue. Make those perpendicular. We're gonna do that. And then make sure these are perpendicular because they don't look to be, but they are. That's goofy looking, but I guess I'll trust it. Is this perpendicular? No, it's not. That's why. Okay, cool. There's our snap ring groove. And these two are supposed to be collinear. Um, yep. And all of this down here is just unnecessary. We'll make you coincide. Now we have a bearing cup. Yeah. I don't know why it stopped highlighting itself. Oh, that might be why. Do this. I don't know why it's not filled in, to be honest. Oh well. Let's make sure all of our relations are functioning normally. Sick. And now we come in and dimension. There it is. Bearing cup height. And we want our wall thickness. Oh, look at that. I made that. Nope. I'm still correct. That's not the wall thickness. The wall thickness is supposed to be here. That can be one thing with making these a little bit too abstract. Uh, Sometimes you just lose track of what's supposed to be what, and it can end up all goofy and bad. Keep it from being self-intersecting. We'll dimension the bearing height. Again, fix it from being self-intersecting. Let's dimension our snap ring groove. I'm not re-saying what each of these dimensions are because hopefully you've got them on lock after making two of these. All right, we've got that. Cool. And now we'll do our lower shelf radius. And this is our bearing radius. Sick. That looks like a bearing cup. We'll do our revolved boss base. Make sure the proper axis is selected, which is our reference line. All right. Very nice. Cool. So now that we have all three of our bearing cups made, don't forget to rename the feature. This is going to be C bearing cup. We're going to start doing the tubes. Now the tubes are a tiny bit more complex this year because we are flattening them. So what I've done for that, which we'll come back to in a little bit, is made a calculator for what sort of dimensions we need to use for the ellipse. So still under control arms Rajan work. Let's take a look at calculators over here. All right, and then I have this file, the circle ellipse equivalency calculator, which I've already got open right there. You put in a tube OD, and then it tells you what sort of ellipse is the same area as that, so you're conserving your area throughout. And do keep in mind that we're putting a diameter input and getting radii output, so don't forget that. Now, back to here. We're going to go, before we start anything, into our equations. And we're going to add two more. We're going to add tube OD, which is tube outer diameter. I'm going to do 0.5 inches for my upper control arm. If you're working on a lower control arm, go ahead and do 0.625 inches. And then tube WT, which stands for tube wall thickness, and 0.049 inches for now. Again, this is a preliminary CAD model and not the final thing, so it's okay for some of these dimensions to be slightly arbitrary in terms of tube dimensions. It is not okay for the bearing cup dimensions to be arbitrary where they interface with the bearing. The wall thickness, the height, some of those things, it's okay, but anything that interfaces with the bearing is not okay to mess up. So now that we've got our tube OD and wall thickness in there, let's actually add two more variables. Sorry, forgot about that. We'll do ellipse short rad, which is the ellipse short radius. And let's take a look at what that is. 0.175. So 0.175 inches. And then let's do ellipse long rad, which is the long radius, which is whatever this value is. Inches. Awesome. Now it's time to start playing with planes again. And we're going to add 3 planes. The first plane is going to be our A reference plane. We're going to come over here and call that A ref plane. Then we're going to add another plane. C is right next to it, so we'll do that one next. We're selecting the line and the node here. Call that C ref plane. And we'll make our B ref plane. B ref plane. Now we're going to add planes in between those planes at the midpoint of each of those lines. So for these constraints, I'm going to start first with the AC. So I'm going to select A and C. And it should show up at the midplane. Yeah, it's down there for some reason, but there it is. And we're going to call this our AC plane. And we're going to do it again for the BC member. So again, that's the line that goes between the B and the C nodes. Oh no, I didn't mean to zoom in. Bam, is that one also somewhere weird? Here, let's actually change something up real quick. We're gonna call this the C ref plane 1, or ref plane A, because that's what we made parallel to the A plane. And we're actually gonna add a second plane in here. And that's gonna be in reference to the B line. So we'll call this one C ref plane B. Ah, okay. Uh, where were we? Yes, here. Okay. C ref plane B. Okay. And now that we've got all that made, just hit Control S, make sure you're saving your progress along the way. We can add our BC reference plane. There's a lot of planes, but these references are good because they make our lives easier later. So between that one and that one, and yeah, it just like snaps to places. I don't really know why, but I guess we can figure it out someday. I'm gonna call this our BC plane. Now time to make the AC tube member. We're going to select that plane and we're going to sketch on it. SolidWorks is going to transport us somewhere else, but we want to be back in this orientation. Okay, cool. What we're going to do is sketch a circle that is coincident with this line right there. So draw an arbitrary circle and draw an arbitrary circle inside of that. We're going to select that, select the line, hit pierce relation, and it's going to snap to the middle of that. What we want to do next is, this is emulating our tube. We're going to specify our tube wall thickness. So equals tube WT. And then now it's time for us to dimension our outer diameter. We'll do equals tube OD. There you are. Now comes the fun part, and the pretty easy part in my opinion. We go features, extruded boss base, and we're going to do a mid-plane extrude. So this is going to be a guessing game. We're going to get ourselves to a length that leaves us enough space to flatten the tube reasonably. Now, this is going to be very much range of motion dictated. So we don't want to have the larger diameter go all the way up to our skinny clevis, because then that larger diameter is going to impact that. For now, it's okay to be slightly arbitrary with this. We can always go back and change things. I like this right here, a 9-inch tube length. We're going to hit OK. And bam, look at that. We have our, what we're going to rename to AC2. And now what we're going to do is add another plane. There's a lot of planes going on here, and that's just because we're rocking with a slightly more complex geometry this time. So what we're going to do is select the control arm line and the bearing cup, and it's going to make a plane tangent to that bearing cup and on the surface of it. And once we make that, we're going to make this flatten reference plane 1. Or we'll call it A1 since we're on the A side right now, and we're going to have to do this for all of them. And what we'll do is make another plane, go here, and we're going to want to have a 1/10 of an inch offset right there. So distance, 1/10 inch. And we're going to call this flatten plane A. Now we're going to start making sketches. So first thing we want to do is sketch on the end of this tube end. And this one's going to be pretty simple and easy, because all we want to do is convert two entities. We want to convert that outer diameter, which is right. Come on. Oh, won't it let me select? Oh, it was there. Okay, we're just going to select this, hit convert entities, and it's going to do that. And then we'll select that inner diameter. And we also want to convert that inner diameter. Or actually, for now, let's just do the outer diameter. And then we'll exit this sketch. don't bother labeling it right now. It's about to be part of a feature. And we're going to go to our flattened plane A, and we're going to sketch on that. And we want to be back here. So here's what we'll do. We'll draw an arbitrary ellipse on that plane. And what we're going to do is add a couple construction lines that make things easy for us. So for construction, and we'll do midpoint in the center to here. Then we'll add another construction line, and we'll go here. No, that's not what I wanted. I wanted to make that coincident with the midpoint over here. And we want to make sure that both of these lines are perpendicular to each other. So now, if we change each of these, those are still perpendicular. Are they? If I do that, those aren't perpendicular anymore, are they? Unless they are. God, dude, I hate SolidWorks views. They are still perpendicular. All right. So now what we want to do is take this shorter one, select our bearing cup reference, and then make those collinear. Or maybe not collinear. We'll do parallel. Yep. And we want to take the midpoint of our ellipse, go to our control arm geometry, line right there, hit pierce. So now it's time to dimension these. We're going to go from the center point to the outside here. Nope. We want to make sure that we're parallel to the line we're measuring. And this is going to be our ellipse short radius. And then we're going to go from here to the longer radius outside. And we're going to dimension this to be our ellipse long radius. There you go. And now that we've got these two sketches, here's what it's time to do. We're going to first create a lofted feature. So lofted boss base, and we're going to select the two sketch profiles we just made. First being right here, and the second being right here. The biggest thing you want to make sure is this little green dot line that it makes. We want to make sure that that is nice and in a straight line. So what I like to do is use my bearing cup as a reference to make sure that I'm looking directly from the top down, and then just click and drag, maybe eyeball it to be close. That did not do what I wanted it to do. Okay. And then just use your control arm geometry line as a reference and then get it to be really close to parallel with that. So now we have that loft, which is cool. And then we come in here and we're going to do a sketch on here. We're going to convert the entity that we have selected right there. Or wait, it didn't start sketching. First, we forgot to rename the loft. Sorry about that. We're going to call that A flatten 1. Or no, we'll just call that A flatten. And then we're going to sketch on this face. I'm starting to realize that explaining CAD while I do it is tiring and also messes me up sometimes. We'll convert that entity to get that. And we're going to do the good old extruded boss base. Hit it with a nice up to surface and then select our bearing cup. Bam, look at that. And so that is what that flattened's gonna look like. This honestly looks really steep to me. Let's rename this to a cope. This does look really, really steep to me, so what I think I'm gonna do is decrease the length of my AC tube just to make it less sharp of a flatten. So we'll take that down 3/10, yeah. And because we made everything nice and in reference, look at that. That's what we've got. Very cool. Well, now we have a solid body going this way, but we don't necessarily want that. We want to make sure that this retains the same wall thickness as before as well. So here's what we're going to do. We're going to go back to our lofted profile. Or actually, first we're going to do the cope side of things. We'll edit the sketch. And then we're going to select it over here like this. And then we're going to hit offset entities. For now, we'll make sure reverse. We want it on the inside. Type something arbitrary in there because we're going to come in here, double click it to be able to edit, use equals, and this is going to be our tube wall thickness. Bam. All right. So we have, if we wanted to look through it, I'm not going to do a section view right now, but this part is hollow. This part is completely solid right now. So what we're going to have to do is do a lofted cut between that. And so I think last time I did this, I added a plane at the tube end. So we're doing this. Here's what we'll do. Go back into this sketch. And like we tried earlier, we're going to get that inner diameter also converted. Sick. And we'll rebuild real quick. We're going to exit sketch and rebuild anyway. It's going to cause a problem with our loft. And so here's what we'll do. I'm going to edit that, delete. We're still going to retain our previous loft selections. Here to here. Why isn't it selecting the profile? The sketch, that is the sketch. All right. And then go here. Same method as before. Making sure that we're looking right from the top. I think what we probably could do is use the plane, the control arm plane, hit normal too. That didn't do what I wanted it to do. All right, never mind, don't do that. My computer's also starting to get a little bit laggy. All right, look at it from the top. Awesome. And make sure that this is nice and parallel to where you want it to be. All right, that's not what we wanted. So what I think is happening is, yep, we've gone from the top to the bottom there. I'm gonna bring that all the way back around to here. Again, make sure that that line is nice and parallel. We'll adjust it on this side. And it did it again. Very nice. What if we do this? Oh, sick. Almost there. I'd say that looks pretty parallel. I'm gonna hit Control B to rebuild. It won't do that because it wants us to hit the check mark. All right, now we're good. No issues, no errors, but this is still a solid body. So here's our course of action. That's good. We're gonna do a lofted cut between two sketches. Lofted cut. And the sketches we're gonna select are, I'm gonna show this sketch, and we're gonna show the sketch that has the ellipse with the wall thickness. So now for our selections, we're gonna come in here, click right up there. We're gonna click right up here. Make sure that that's a good, nice straight line. All right, make sure that we're not having that silly top to bottom thing. We want these to be on the same side. So now they're both on the top right there. That's what we want. Um, I'd say that's parallel. Cool. And we're gonna do a cut. Awesome. So we're gonna call this the A flatten supplement. We can go ahead and hide those sketches again. Now we've completed one side. So what we've got to do is repeat that same process over here on the C side now. So here's what we got to do. We got to select this. We got to sketch, or what did we start with last time? We started with the flatten reference plane and then the flatten plane, which was 1/10 of an inch away. So we're going to go to features, add our flatten reference plane on the C side, but this is on the A, so we're going to call it C flatten ref plane A. And then we're going to make another plane off of that. And we want 1/10 of an inch. Cool. And we're going to call this the C flattened plane A. I'm going to pause this video real quick. And we're back. All right. Where were we? We just made the C flattened plane. And so we're going to sketch on our tube end surface right here, convert those entities over. So I'll select the face, hit convert, and we'll select that inner radius if it lets us. Okay, hit convert. Awesome. And we're gonna Control B that, exit that sketch, and then we're gonna sketch on our flattened plane. Cool. Which side are we on? That side. We're gonna make our arbitrary ellipse. Bing. Remember to add those construction lines to make our lives easier. Make sure that it's for construction, like I didn't do there. Right, and now we're going to keep these two perpendicular, which they naturally should be, but just in case, we're going to make these two parallel, and we're going to make that center point pierce this line. Bam. And now what we'll do is select this, hit our offset entities, reverse, and remember to dimension this as our wall thickness equals ellipse. Oh, nope. We want tube WT. Sick. And now it's time to dimension our short and long radii, which is here to here for short. Make sure you're measuring parallel. Equals ellipse short rad. And let's do our long rad. Oops. Awesome. And now that we've got this, we're gonna do our extruded boss base up to surface, up to the bearing cup. That looks good to me. Again, do make sure that it's hollow. You want to make sure that it's actually emulating the wall thickness of the tubing that we're using. And we're going to call this our cope, C cope A. Ready? Now it's time for the loft. So we'll do our lofted boss base. We're going to select this profile, and we're also going to show our ellipse profile, which is in this sketch right here. And select that. Hold on. That. All right, back in business. Now let's get ourselves oriented. So we're looking at a good top-down view. And make sure this is good and parallel. Oh, it's good to me. Hit OK there. Time to go in and do our cut. After we name this, we're gonna do C flatten A. It's cut time. Features, lofted cut. And we're gonna choose that. And that sketch got hidden, so let's reveal that real quick. Part of our flatten feature. I'm gonna hit show. It doesn't like that we didn't click the check mark in between selecting things. It's a little annoying at times. Sometimes it'll auto-select it for you, other times it'll make you click the check mark. All right, so let's get these good and in a straight line. Something real quick, all right. I'm gonna bring it closer to here so it's easier for me to gauge whether or not it's in a straight line. And so when I'm zooming in there, what I'm checking is to see if, obviously, like I'm not looking exactly normal to it, but to see if it's on the front line or the rear line to make sure that it doesn't do the weird top to bottom thing that was happening earlier. And we're gonna cut that. Awesome. Just like that, we've now completed the first control arm tube. Very nice. Time to do the second after we name this. Our C flatten sup instead of supplement A. Let's start organizing this into folders real quick. Staring at a giant tree sucks. And we'll make that part of the geometry. From here to here is all bearing cups. Oh my God, I didn't hit new folder. Okay, bearing cups. And then from here, we'll leave those. Nah, we won't leave those. Let's do all of these. I wasn't holding the shift key. I'm gonna planes. And then from here to here, we're gonna add this to AC tube. Oh, we're just gonna call it AC. All right, well, time to continue. We're gonna do the same process that we did with the AC arm for the BC arm. So here we go. We're going to use our B reference plane and our C reference plane B. Oh, wait, never mind. We already have BC plane made. No, I didn't mean to make you. Bye-bye. So we're going to sketch on the BC plane. And yeah, instead of the plane being all the way over there, we're going to go to where we actually want it to be. We're going to draw a circle. Remember, arbitrary and then add relations later. So we smart dimension that to be our tube wall thickness. And this to be our tube OD. And now we exit the dimension tool, take that, and let it pierce our geometry line. Bing. All right. Time for our mid-plane extrude. And we're not going to use 9 inches because this arm is a lot shorter. So we'll just do that. I have a feeling, yeah, 6 is going to be good. Nah, let's do 5.7. Yeah. Right now, this is just vibe based. Obviously, like we did last time, once you make the flattening feature, make sure you look at it. It's not too flat. That's something you can adjust later. And we're going to call this, similar to what we called the AC part, as BC tube. Now it's time for our loft and flattening features. Yay! We're going to start with the inboard side first, because the outboard side for this one's going to be a bit tricky. And yeah, we'll get to that later. So let's add the plane that we need. It's going to be there. Hello, let me click, please. Excuse me. I think it's put some sort of filter on it real quick. But we go back into plane selection. Why won't it let me click the geometry line? All right, I'm going to pause the recording, see if I can figure this out. Problem evaded. It was something pretty small. I had faced this before as well, so I kind of knew what to do. But if you see that little purple funnel next to your mouse and it's not letting you click anything, go up to the feature search bar, go to filter, and then hit toggle selection filter. So that'll turn your selection filter off and then actually let you select things again. I don't know why it auto implements that. But there's that plane. We're going to call this flatten ref plane B. And once that's made, we're gonna sketch our, or no, we're gonna make a second plane 1/10 of an inch off of it. There you go. And we're gonna call this flatten plane B. Now we're going to sketch on flattened plane B and do our ellipse. Draw our ellipse. Time to add our construction lines. No, that's not where I wanted it. Make sure these guys stay perpendicular to each other, which they will, but just adding it in there as a precaution. Make this line right there parallel to the bearing line. And then we're going to pierce the geometry line. Yeah. And let's not forget to do our good old offset entities in the other direction because we want it on the inside. And we're going to specify this to be our wall thickness. And then now time to dimension the ellipse itself. This is our short rad. And then we got our long rad. I wonder if it's just the angle or if okay, yeah, it was just the angle. From here it looked like, yeah, those distances were different. Cool, now that that's made, we do our good old boss base up to the bearing cup. All right. And then we're gonna do our lofted feature now. We're gonna call this cope B, B cope. It's time for lofted boss base. And let's show those sketches from earlier. Did I forget to convert that? I did, didn't I? All right. We forgot to convert entities, the tube end. So we'll sketch on there. Convert these. Convert that inner diameter as well. Don't forget that. Awesome. Loft time. Make sure you're showing all your sketches. This one's going to be inside B cope, so it needs to be shown. And we'll select the outsides first. Make sure to click that little check mark or else it will get mad at you, like we found out earlier. Awesome. I really wish it would just auto fix to being good and parallel. That's close enough, I'd say. All right, that's good. So now we got that loft going, which is B flatten. And then now it's time to get that cut in there. I'm sort of hopeful that there's a better way to do this instead of lofting and then cutting, but from what I found, you can't loft like individual or like an inside sketch area, similar to what we did with the extrude boss base. Show that. It's really annoying, but hopefully we'll find a solution someday. There. Awesome. Get ourselves in a good view. And now it's time. C, that's on the back face. And this is on the front. Looks fine to me. And we're going to use this as B flatten sup. So that's this side done. Now it's time to do this side. So this one is a tiny bit tricky because what we want to represent here is not both of these intersecting, but since this arm goes all the way up to the bearing cup, this arm is now only supposed to go up to this arm and then the rest of it hits the bearing cup. So I toyed around with different ways of doing this, but what I found to be the most helpful, so to say, or the easiest way to do this is to just continue with our normal way as if we're extruding it to the bearing cup and then come in from this side and cut out whatever is hitting here. Unless it'll let us, with our extrude, unless it'll let us do up to both of these bodies as a constraint, but we'll see how that goes. Still working in the BC part, but we'll go ahead and add this to the folder BC. Time to do the same thing over here with our planes. So there and there. All right. And what did we call this? Yeah. Flat, plane, ref, C, or what do we call it on the C side? C flat plane ref, okay. Typo. And then we're gonna add another plane, which goes right off of that. 1/10 of an inch. Awesome. Hmm. All right. Anyway, back to what we were doing. Sorry, I had to pause to think for a second. C flat, plane, B. And let's sketch on that and get our ellipse ready. Come on. I'm gonna pause this recording and then share an update in Slack real quick about how this is. All right, we're back. I just told people I'd have this video ready in like an hour, and I looked down at the clock and it's been almost 2 hours. Oopsie, forgot how long this took. With the old process, it was a lot simpler, but it's also a heavier design. And so we're gaining complexity here, but we're also making a lighter design and ideally a better design. Don't forget to make these for construction. We'll add parallelity, which I'm hoping is a word. And let's not convert. Let's just do the offset entities while it's here in the air. Make that our wall thickness. And then here we come in with our short and long dimensions. All right. And now that that's dimensioned, oh, look at that. It's what I talked about earlier. I didn't hit my equal sign. There you go. That's better. And let's get it to pierce the geometry line. So here's one cool thing now. We have this show up. So what we'll do in this case is we'll do a projection. So project this face onto here, which I think, yeah, is under convert entities, silhouette entities. Then we'll silhouette this right here. Oh, not, it does that entire thing, doesn't it? This was working a lot better when I was doing individual bodies, but yeah, here's what we'll do. We'll see what extruded boss base up to the surface does. Unless we use this surface as a constraint. Oh no, it doesn't like that at all. Here, let me pause this video and figure out how to do this in one body. We'll be right back. All right, I think I got it. Here's what we're gonna do. It's a tiny bit sketchy, but we're just gonna continue to convert, or not convert, extruded boss base these up to the bearing cup surface. And then we're just gonna move this cutout feature to the bottom, or yeah, add another cutout feature, a lofted cut, to get rid of everything over there. So again, sketchy, probably not the best engineering design etiquette because we're just adding unnecessary features now. But it's convenient, and so I'm choosing to go forward with that. One cool thing about it being part of the same part file is that you see it merge over here. Now we're going to do our loft after we convert the entities on this side. Convert, grab that inner diameter, convert. Awesome. Oh, did it convert it? Okay, cool. Sweet. Time to do that loft, which we forgot to name this our C Cope B. And we'll show the sketch. And do loft. There's... Not gonna lie, being on CAD for this this long at a time really takes it out of you. So if you're just trooping along and you're still here and doing this in one sitting, big ups. Well done. If not, hopefully you were able to pause and replay this video multiple times. That's more on the front face, yeah. All right, cool. We're gonna do that. Call this our C flat B. And then we're gonna do that internal cut. Make sure our sketches are showing. Show. And we'll perform our lofted cut, which is between here and here. Get that nice and parallel. All right. And we're gonna call this, what was it called? Yeah, C flat sup B, as in supplement. All right, so that should be good. I'm actually a little intrigued to see whether it actually did do the goofiness. I'm gonna go off the right plane. And by goofiness, I mean, let's see if it did it. Yeah, it did. Okay. So I thought it maybe might have ended the feature that we just added for the B arm early, but you can see right there, you've got the presence of that arm inside the other, which we don't want. So we're gonna continue with our plan to do our good old lofted cut. And so honestly, if we took our C flattened sub A and then just moved it to the bottom, that should take care of that. And then we can just do an extruded cut over here, which, yeah. So we'll do up to surface. No, we don't want that surface. We want this surface. No, why are you doing this? Yeah. Well, we'll see what it looks like with a section view again and see where that got us. Go off the right plane. Section views are pretty helpful for diagnosing things like this. Oh, look at that. So we're mostly chilling, except for the fact that we, yep, do still have that little nugget in there. So I'll probably just add a new sketch and then do it that way. Almost done, guys. Almost done. We just want to make sure we don't have that intersecting in there. And so that goes off of the, which plane was it again? It was the flattened plane, C flattened plane A, right? Because this is the AC tube, this is the BC tube, and that's what we're cutting, yeah. So we're gonna go up to our C flattened A. What the hell? I just want to sketch on you. Right. And that's this side. We're gonna take this, we're gonna convert, and we're gonna cut. It didn't work. Oh, it did. It's just because it's inside. So we'll do an extruded cut now. And we're gonna go up to surface and see if it likes us this time. No! Why? What if we went up to body and did that? Will that do it? No, it can't. Up to next, maybe? No, now it's cutting in the opposite direction that we want it to. I just want to, oh wait, what if we do this? Oh, beauty. Perfect, up to next word. And so now let's double check this with a section view. We're going to call this a housekeeping cut. Let's go off that right plane again and bring it out. No, I want it the opposite. What? I want to be able to see the other side. How do I do that? Let's chill. We can still see what we want to see through here, maybe. Oh, look at that. Yep. That's perfect. That's a good cut. It's a good cut. Awesome. So now that we're done with that, we can add all of these features into our BC folder. Non-contiguous features cannot be added to a folder. All right, well, I don't know what non-contiguous means, so I guess we'll just have to leave those out of the folder. We're gonna hit Control S. And yeah, there we have a control arm. Now, the reason we wanted to make this as one body is because we now want to add fillets to simulate welds. So we're going to come in here, feature, fillet, and we're going to select all of our edges where there's going to be a weld bead. This being one. Here is another. And then another one over here. Oh, it's not liking that. Okay, we'll add a weld in between here. Then try to do that. No, it doesn't like that at all, does it? That's interesting. See what happens if we click OK. But then we want to add a weld at the other bearing cup as well. And we'll see what it tells us. Okay, so it's telling us it failed to create the fillet. Oh, I think it might be a radius thing. So we'll try half of that, see if it comes back. Oh, and it does. Awesome. One thing to check is to check with your welders and see what sort of fillet radius you're going to be working with. We'll see if 0.075 works. Nope, doesn't. So 0.05 inches, I guess, is the move. And look at that, we've now simulated welding, which is really good for being able to somewhat accurately look at stress concentrations when you have a good fillet in there. Now, if you are making either the front upper control arm or the rear lower control arm, you can stop at this point. If you're making the front lower control arm, I'm sorry, but you're gonna have to keep going with me. So again, front upper and rear lower, you guys are good. This is your part, done deal, well done, thank you for your help. Now, hello front lower person. This is operating under the assumption that the front lower has the pushrod pickup. That might be subject to change depending on what happens with SLP stuff. But what we're going to do now is add a gusset plate. So here's what we want to do. We want to add a plane. Let's do over here. And we want to have it on that surface right there, the top of the bearing cup. And we're going to call this the gusset plane. And we're going to come on here and we're going to sketch. And now that we're sketching here, we're going to want to convert entities our control arm geometry onto this sketch. Now, what we'll do is add a line. No, there it is. Gonna add a line between here and here. Now, this line, try to have it at an equal angle on both sides, meaning that each of these line segments are equidistant in length. So we're going to add two construction lines to make that easy for us. Right there, right there. Look at that. Or actually, that construction sign line was kind of useless. We're just going to trim entities and do that. Sick. Now we can add a equal relation between these two lines. Awesome. And so what we also want to do is convert entities the face of the bearing cup over here, that outer edge. And so now we can come in and trim. Boop, boop. And we'll trim these sides too. So we're back to having a full face. Awesome. Why is that so high up? Oh, we didn't make it coincident to that. That's funny. All right. So now that we've done this, we're gonna dimension. Actually, before we dimension this real quick, we're gonna go to our formulas, our equations. And we're gonna add something called gusset plate length. And for now, we'll make it 1 inch. Oh, forgot to type inch. 1 inch. And this is what we're going to use to dimension the gusset plate. Oh man, we're not in the sketch anymore. If anyone still watching this wanted the true experience of what a late night kind of design session looks like at the formula shop, this is pretty representative, I'd say. It gets kind of quiet at one point, and you just kind of sit there and do your work. All right. And now what we do is exit the sketch because we defined our plane wrong. We want to make this coincident. Or maybe not coincident. What if we added this? No, it doesn't like that. Or I want this face. So this is 4/10, and I know it's 1/2 inch diameter tubing. So, maybe this is actually fine for now. Well, then we're gonna have to edit this sketch. Or no, that's not fine for now. We're gonna want this to be coincident. And that's actually gonna change a lot of what we did here. And by change a lot of what we did, I mean, let's start over. What we want to do is project our silhouette of this body right here. And see what that gives us to work with. Awesome. So now we have all of this information. What we're going to do is delete just about everything except for this inner triangle right here. We'll use trim entities and then just go at it. We want to get rid of all of this. Bing, bing, bing. Awesome. Those fillets are a little annoying at times because they're mad small. And now we have all these gone. Sick. Now what we're gonna do is use these, make them for construction. Or before we make them for construction, let's offset them real quick. And we'll offset by 1/10 of an inch. Yeah, I'd say that's pretty good. Let's do 0.15. Again, this is all super dependent on what your tube OD also is. What I'm trying to make sure is that what I create here doesn't surpass that inner diameter, because I don't want this going inside the tubing. If it's intersecting to the point where they're touching, SolidWorks will merge them together. But if I have a tube and I have a feature going in like this, that inside part will still be there, which is annoying and introduces a lot of inconsistencies. Here's what we'll do. Go like that. Make these for construction now. And then we're going to add a line right there to represent our gusset plate. Let's now go ahead and trim these. We're going to move this dimension over here so that it's better, I guess. And we're going to make these portions of the line. Oh, did it not trim properly? Oh, I didn't trim the outside. Bam. There it is. That's why that dimension was still there. So then we're going to make these equal length, just like we did last time. And we're going to add our dimension. We'll go from here to here. That's not going to give me a dimension, so I guess I'll just go from the inside right there. Come on, deselect everything. All right. So I'll go from this point right here to this line. And I kind of want it to, yeah, that's good. So we'll have 1 inch there. Or no, not 1 inch, because we dimensioned this as part of our equation. Equals gusset plate length. What happened? Oh, okay. And now we're going to extrude. We're going to hit up to surface of this contour. Oh, if I do up to body, that'll be cool. Up to this body. See if it will do it. No, it doesn't do it. So we'll still do up to surface. Or no, screw all of that. We're just gonna do blind. Yeah. And just gotta make sure, no, it is intersecting there. So we'll use 1/16 inch, which does that. Yeah, we'll use 1/16 inch there. And to offset this, what I'm gonna do is just make the plane that it was built on a bit higher. What's wrong with you? Just fixing that error right here. Just set to 0.15. Now we're gonna come to gusset plane. Well, we'll name this gusset plate. And we'll edit the definition. Oh no. Oh, wait, yes, this is what I want. So we'll make it 0.05 taller. And so now, yeah, we shouldn't run into any of that intersecting issue like I talked about earlier. Awesome. Very cool. And what we're going to do now is hit this. I'm going to hit mirror. If I can find where it is. There you are. We're going to mirror this across the Ruka plane, which is in geometry. No. Should... Oh, okay. It's because I'm in the main assembly right now. It's totally okay for you guys to do this in your part files, by the way. Oh, wait, sorry. I totally did the selections wrong. We want to mirror about the Ruka plane, and we want to mirror this feature. Look at that. And just like that, we now have our gusset plate in there. Awesome. Very cool. Let's see things. Yeah, there's that little gap in there, which we can probably get rid of. But for now, it's chill. If you want to get rid of that gap, go ahead. Now, if you're making the front upper control arm, this is your stopping point. Given that the Fuka, well, yeah, no, the Fuka won't have it. The Fulka for right now won't either, but yeah, unless you're working on any arm other than the rear upper, this is a good stopping point. Now, if you're working on the rear upper, it's time to add the toe link bolt, the holder. So let's rename this to gusset mirror. All right. And we'll add that to its own folder. Gusset. Now what we want to do is add a point for this toe link right here. So here's the plan. Here's the ultimate master plan. What we are going to do is sketch on the Ruka plane that we made a while ago. And we're going to add a hole over here. So arbitrary circle, make it coincident. And we know that our toe link is going to use M6 rod ends. So we're going to make this, I wonder what the clearance hole size for an M6 is. M6 clearance hole. So this is what I'm looking at right now. We use the metric clearance hole chart. M6 clearance hole, we want close fit, so 6.4 millimeters. All right. 6.4 mm. Very nice. And we'll dimension a distance from here. And we'll call that 3 inches for now. This is going to be a really short toe link. Run it back. So this we can definitely change. In fact, let's actually just add an equation for that. We're going to call this the toe pickup length. And I changed my mind. I want 2.5 inches. We're going to hit OK. It's going to update everything. And we're going to edit this sketch and change it to 2.5 inches. Nope. We have an equation. This is the toe pickup length. All right. And now that we have that, here's what we shall do. We're going to leave that there. And we're going to call it our bolt hole, toe bolt hole. Now we're gonna add a plane. Actually, we're gonna use the same plane that we used for the gusset. Uh, are we? Yeah, we will. We'll use the same plate we used for the gusset, and we're gonna sketch on it to make our toe link holder. So the main constraints with this is we want to make sure that we're able to package the toe link properly. Let's get a good view going. What I highly recommend is pulling a rod end into an assembly and making sure you have clearance here to do whatever you want. And now we want to convert entity that hole, and we also want to do a cheeky little offset entity. And we'll do 1/10 of an inch. Perhaps more than that. Yeah, like the 0.15, or we'll do 0.2 inches. Now this is going to be dictated by bolt tear out, which is a concern with these. We're going to do a similar story with silhouetting our entities onto here. And then we'll just trim whatever we don't need, which is everything, just about, except for this part right here. So we can now get rid of all of this. And then we can get rid of this inside stuff too. And then we'll get rid of all this over here. Awesome. Now that we're left with that, here's the game plan. We're going to draw 2 tangent lines. And that's about it, man. We're going to make this tangent to here. And we're going to make this tangent to here. Which it already is. Sick. And now we're going to add a tangent line there, which, yeah, okay. And we're going to add it to somewhere random over here. And what we'll do is just make it parallel to this side. So I'm thinking perhaps doing this on the gusset plane wasn't the best idea. Yeah, I don't think it was. But no worries, we're gonna try something and see if it breaks it, which is a fun little game I love to play. All right, now we get a full feature. All right. So we're gonna rebuild real quick. And then we're going to make a new plane, which is right at the top of these bearing cups right here. We'll do coincident, and we'll call this toe link plane. Or toe holder plane, actually. Here, hold on. I said I would have this done by the end of the hour. It's the end of the hour. I'm gonna update Slack real quick. We're back. I'm updating Slack so much because I've got people waiting on this video. So it's only fair to tell them. All right, now that we've made this plane, we're gonna move it to above over here. So that way we can now right click this, do edit sketch plane, and then just change the sketch plane to the toe holder plane. And we're gonna see if that works. I really hope it does. Oh, I think we did it. I think we did it. Look at that. That's incredible. Nice. All right, sick. And now we do our little extrude. And so we want to, I don't know why that's not registering as a contour. Everything is closed. What if we made this for construction? What happens then? No, still not cutting it. Um, I quite honestly do not know what's missing. Unless it just magically decides that it's okay now. Or let's get out of this boss extrude mode. And yeah, we are still editing this sketch. Try to move things around maybe. That's really funny. What if I delete this line and then add it back? Because I could have sworn we had a complete profile like 5 minutes ago. Boom, 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 boom. All right, I'm gonna pause this so you don't have to deal with me, but I'll come back once I figure. All right, so I think I figured it out, but I just wanted to show you guys something funny. Uh, I don't know what's going on, but here is it sharing? Yeah. Over here, I zoom into this line, look what happens to it. Then it disappears, but look at that. I noticed it because it started to look a tiny bit squiggly. I think it's just a graphics processing issue for my laptop. Now, if I make you go away, are you gonna fix my issue? Okay, sick. All right, awesome. Now we extrude it. And we're using 1/10 of an inch. Wait a minute. Ah, that's not what I wanted. But it's close, so it's okay. Actually, we're not going to use a 10th. We're going to use a 16th, just like that. I'm going to offset a good bit of these things. So first, let's go ahead and get that mirror done. I'm going to call this toe holder upper. And we're going to mirror it. It's the Ruka plane that we're going to mirror about. And the feature we're going to mirror is the toe holder upper. Awesome. Very cool. But so it's a little goofy looking right now because we messed up that sketch a tiny bit. I messed up the sketch a tiny bit. But this is what it's supposed to look like. What I highly, highly encourage you to do is use the measure tool over here. Well, first pull the rod end into an assembly. But if you don't have that just yet, measure this right here and make sure that you've got enough room for a rod end. So let's actually just check that real quick. Let's go on to McMaster car. And let's look at an M6 rod end. We want lubrication-free ball joint. And we're looking at overall thickness, 9 millimeters. Hey, Google, what's 9 millimeters in inches?
9 millimeters is equal to 0.354 inches.
Oh, so we need 0.354 inches there. And we currently have 0.275, so that's not going to cut it. It's not going to cut it at all. So let's explore maybe reducing that thickness there or a different attachment. So let's go back to this sketch right here. Here's what I think I'm going to do. I'm going to delete all of this part where it connects to the bearing cup and have it just be something that welds onto the arm right here. That's going to induce a pretty nasty bending moment, in my opinion, about this, but we'll let the FEA speak for itself. So we'll get rid of all of these, and then I'll add a little line that goes like this. And then I'll dimension a silly little angle. Where'd it go? There you are. We'll call that 140 degrees. Good number. Good even number. Nah, I don't like that. 150. Bam! It's too easy. And now we'll trim. Ooh, look at that. Sick. Now, what about this is undefined? Oh, the lengths, right. We're gonna call this 0.825. See what that does for us. All right. And we're gonna rebuild. Okay, the mirror has a rebuild. Error. And we'll see. What is it erroring? If I just do that, is it gonna fix it? No, it's not. Some feature instances are disjoint and will not be created. Use the button. Oh, I think. So we want that Rika plane, and we want to use the tool holder upper. And we'll see what it tells us. Why is it not doing it? Hmm. I don't really know. Maybe if we fix it to where this is actually touching the rest of the control arm, it might fix itself. But that's our next task. We're going to want to take this section and have it be closer to the control arm. So what we're going to do is delete this silhouette on edge relation, which should give me the ability to move this line. Oh, look at that. Beautiful. And just like off of vibes, purely off of vibes, I'm going to call this 0.2 inches. And we'll see. Doesn't look like that's going to intersect. Yeah, does not look like it. We got to get closer. So let's check 0.1. Oh, look at that. We're intersecting. We are intersecting. We might be intersecting a bit too much, which we are. So let's try 125. 1.3. I think I like that. Yeah, I think I do. And we'll dimension this length right here. And that should fully define the sketch. Yeah, we'll call this 0.7. No, the shorter it is, the better. Let's see what playing with this. No, we'll leave that. Yeah, the shorter it is, the less steep of an angle we have there, and that's what I'd like. No, I don't. Stop. Why are you at 70 degrees? Okay. So we'll make this a 1/2 inch, see where that puts us. Okay, it puts us over there, which is good, which is good. And now we're gonna rebuild. Look at that. It did fix itself. That's pretty sick. Big fan of that. So now you've got a tow holder, but we're not done, man. We're not done yet. Because we have to do tow holder mirror. And we'll add this to its folder. Oh man. What if I just left the mirror part out? Sick. Tow holder. Cool. We have to add weld beads. Welding is important. So here's what we'll do. We're gonna come in to fillet. Let's fillet 2. I wonder where fillet 1 is. Well, here's what we'll do. We'll just move fillet 2 all the way to the bottom, and we're gonna select all of our faces or edges in one fillet feature. I like to fillet all of my parts. The only reason I said that is because my roommate told me to when I told him I was going to be recording this later today. And unfortunately, I don't think, yeah, the fillets don't carry over to the other side on a mirrored part. So I really hope the audio is okay. I didn't test anything at all. Frankly, if you're still watching this, I either assigned you to this design project, someone else assigned you to this design project, or you really just have nothing better to do with your life, man. Which Sorry to hear that. Yeah, no, if you're this far into the video, big preach. Thank you for watching. Make sure to like and subscribe. Man, I said I would stop making those jokes, but here I am making another one. I do think they're funny though. Do think they're funny. So I don't know why that fails doing the fillet. Maybe if we go to 0.04, it'll feel a bit better about itself. Nope, still doesn't like it. That's a little funny. So we'll go back to 0.05. And we're going to contemplate a tiny bit as to why this might be happening. So I'm going to hit that. Yeah, no clue, man. So frankly, I'm kind of tired of this. So I'm going to move on and then we're going to weld over here. Man, same thing. Are you kidding me? Well, that's the problem right there. Is what it's telling me. Well, just make sure you put welds on your toe link or oh, what if we put a weld down here? Yeah, look at that. Sick. Awesome. That works for me. And now you have oh, that's a sharp corner. I don't like that. Glad I caught myself. Because we're not done yet. All right. We're gonna do this. And we're gonna do this. Like that. Let's hit it with some fillets in this realm too. Wonder if it'll do this. Hmm, doesn't look like it likes it. Well, that's good enough for me, friends. Thank you for watching. You've got yourself a control arm with flattened ends on the tube, and you've got yourself one that's made well, because at any point, if we want to change anything, we can just come in here to this equations tab and change whatever we want, man. It's dynamic, it's good design practice. You know, let's just say my bearing cups are a little thin. And so I want to change the wall thickness of my bearing cup from 0.1 inch, doubling it to 0.2 inches. Watch this bearing cup right here. I'm going to hit enter. It's going to take ages to update. Bam, look at that. Nothing else about the control arm changes. All of the geometry is retained. Everything's still good. And I spoke too soon. Not everything's good. That's broken, but that's a quick and easy fix. There's not supposed to be a hole there. That's a very quick and easy fix. So thanks for watching, guys. I really hope you learned at least something while looking at this. We're going to change that wall thickness back because it's painful to look at. But I really do hope you were able to learn something through this process. I'm sorry this is a very long video and very ill formatted, but 'tis the way life goes sometimes. I decided to just start Zoom recording and talk while I'm designing. Oh, look at that. So that's not good. The fact that we've got this cut going up to this face right here. I'm going to fix that real quick. What feature is this? This is the housekeeping cut. That was the problem one, wasn't it? Yeah, I didn't like it. So here's what we're gonna do. Instead of going all the way up to there, let's I don't like that I'm not able to do up to surface to here because then it just jumps through like that. Up to next, then puts it there. Offset from surface, maybe. Oh, genius. Beauty. Now we just, what the fuck? Okay, so we're gonna get this close. So let's go 0.001, a thousandth of an inch. So that should be good. Look at that, guys and girls, and whoever's watching this. we have a completed rear upper control arm that's ready to go into FEA. Final step is to add a coordinate system that is planar with this. I'm gonna keep it 100. I don't really remember how to add a coordinate system. Psych, I do remember how to add a coordinate system. So our x-axis is going to be along the Ruka plane. Our y-axis is also, actually, let's add some construction lines for these axes. While we're here, we might as well. I realize that I've pseudo ended this video like 5 times already, but we're back again, aren't we? We're back again. We're going on the Ruka plane. I hope you guys enjoy hearing the sound of my voice or just spending time with me. I'm like very, very ready to accept that none of you have stayed to watch this way and I'm talking to nobody. But we're gonna add 2 lines. We're gonna add 2 lines. We're gonna go from here. And yeah. We'll go arbitrary. Fuck it. That's gonna be a good, nice horizontal or vertical relation. Or no, is that horizontal? This one's gonna be whatever the opposite one is. What the hell? That didn't do what I wanted. Then we're gonna add a nice second one right there. Oh, so now you don't snap to a relation. That's funny. We'll make these, we'll make this horizontal. Nope, we're gonna make it vertical. Bam, look at that. Look at that. Both of these for construction. For construction. Awesome, 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 awesome. And we're gonna call this the coordinate axes. Axes with an S. Now we're gonna add a coordinate system. And we want the x-axis to be along this line. We want the z-axis to be along this line. And it doesn't really show us what it's doing, but I'm gonna hit OK and see if it solves for that. And I'm gonna see where it put it. Hello. Okay, so we need to flip the x-axis around. I didn't do that right, did I? Nah, I didn't do that right at all. Man, I thought I would make it planar with that. Well, we're gonna delete this. I'll figure out how to do the coordinate systems later. Thanks for watching, guys, and girls, and whoever's watching this. I appreciate your time. Once again, hope you learned something, and I hope whoever's doing the FEA for you doesn't throw a fit about this. If you're watching this in the 2024 design cycle, I won't throw a fit because I told you to do it. So yeah, there's a good chance we might add like a black backing plate or something back there. But I'm rambling. This video's over. Thank you, and I will see you next time. Bye-bye.